The Inventive Podcast, mixing engineering, fact and fiction.
Inventive.
With Trevor Cox, Professor of Acoustic Engineering at the University of Salford.
Welcome to the final episode of the current series of Inventive. Now, we started this series off by intermingling space travel, engineering and rap, interweaving those components together to make a wonderful episode. And we're going to do the same today, but this time it's going to be the interview and some great poetry.
Imagine you could send your eyes on an 8-month voyage to a rust-red wasteland, parched brick dust and a wind keener than ice.
Our engineer today is Jack Haworth, who works at the Sellafield nuclear site, creating robots that go to the most extreme environments.
There's 2 robotics platforms that I'm working on. One's called Mirax. It goes into a nuclear cell which is very highly radioactive, so you wouldn't want any humans in there, and then it can map out any radiation hotspots within this cell. So these are areas where people have probably never been, so it helps towards decommissioning and making it safer for everyone.
But first, we're going to do something a little different today. We're not going to talk to our engineer first, we're going to talk to our poet who has created a work based on Jack's story.
Inventive.
My name is Katrina Porteous. I'm a poet from Northumberland, and I have absolutely no background in science whatsoever. Not even an O-level. To my shame.
There's no shame in that. Just be thankful we're not hearing a poem I've written. Even a Vogon would be unimpressed by that. Now, Katrina, what did you take from how Jack talked about robotics?
I found Jack's language really interesting. The language of control, which he uses, computer numerical control, master-slave manipulators. It's very extreme language. And in the course of researching for this project, I found out that the word robotic itself is derived from a word meaning slave. Control is a key concept in computing, and I wanted to explore that, particularly because our whole world seems increasingly dominated by these data-driven systems which impact on ideas of our own social freedom.
And maybe in contrast to sitting down and writing a work of fiction, in Jack's work there's a lot of talk about collaboration and, being so important to him, and it's embedded at all stages. I mean, what did you take from that idea of the collaborative nature of engineering?
I found that whole area of collaboration absolutely fascinating because it's something which occurs in so many different aspects of what he was talking about. So in particular, he was discussing how teamwork brings many different perspectives to a problem. And I think we're all familiar with that. The more diverse your perspectives, the better placed you are to tackle a problem. But I couldn't help hearing in what he was saying echoes and resonances from a very long tradition of philosophical debate about practicality and theory, or body and mind. And that sort of led me on to thinking about some of the engineering processes which he was describing and processes of nature. And so the idea of engineering and logic-led systems taking some of their models and some of their metaphors from nature, and that kind of collaboration I also found extremely interesting.
Yeah, and in Inventive, it's been a delight for me to see how the work of engineers and writers resonates. I mean, sometimes the connections are more surprising than you might expect. I mean, did that surprise you that there was a connection to Jack as an engineer and you as a poet?
It didn't surprise me at all because I've worked for a number of years with scientists and have long felt that the distinction between the arts and the sciences is an extremely unhelpful one. I mean, we're all, as human beings, inquisitive. And we're all creative problem solvers. And whichever area of discipline we come from, we're more or less doing the same things, I think. We're engineers and artists in particular are imagining new worlds. And it's about the imagination. And that was what caught my imagination in responding to Jack.
Yeah, and maybe you could tell us a little bit about the work that you created, this poem Ingenious.
Yes, well, I was I was very careful to listen to Jack's words very closely as I was writing it, and then I did some reading and some research around about what he was talking about as well to sort of amplify what he was saying. But the poem itself, as I wrote it, divided into 4 sections. But the whole thing is unified by metaphors and by a sort of chorus, which comes in like a song chorus. And then when we put the piece together, we created a sort of dialogue with Jack's interview. So the poem and the interview are commenting on each other in its 4 parts. The first section deals with the idea of the extension of human senses and actions beyond the body. And it explores that language of control that we were talking about as well, and raises the possibilities of human-machine collaborations. So those themes of control and collaboration are set up in that first part. And then the next part goes on to deal with the work that Jack does with remote vehicles. He talks about Karma and Mirax, and these are remote vehicles which deal with the hazardous legacy nuclear waste at Sellafield. And I watched some videos online and to see how those worked and described them very closely in that section. And then I went on to compare Sellafield's extreme environments with Mars, because I wanted to introduce this idea of space quite early on in the piece. And also to introduce the idea of cybernetics, which is this idea of using nature as a model for systems and providing metaphors for engineering really from the natural world, from the idea of feedback. Then in the third section, the poem goes on to extend Jack's description of his work in extreme environments into outer space, which Jack doesn't really talk about, but I wanted to sort of push the ideas that he was discussing into a different environment altogether. And then finally, to look at autonomous vehicles surveying the moon for future mining operations. So the last part of the poem then really goes on to explore the possibilities around this and some of the more sinister potential of these ideas of control and artificial intelligence and intelligent automation for social control. But then also, much more optimistically, it focuses on the role of nature, so the physical body and human empathy and emotion and what we have in our conscious intelligence, and how really freedom and hope lie in the possibilities for collaboration between human consciousness and then machine learning. And I find that an incredibly exciting prospect.
Thank you very much, Katrina. I'm really looking forward to hearing your work in Genius. But before that, let's meet our engineer, Jack Haworth.
Inventive.
My name's Jack Haworth. I'm 26-year-old. I'm an electrical engineer graduate working for Sellafield Limited. I'm currently working for the Robotics in Extreme Environments Lab run by the University of Manchester, where they design and develop robotic solutions to problem statements from Sellafield.
So robots in an extreme environment sounds dangerous but exciting. So what are you working on at the moment?
Yeah, so I'm working on 2 robots. One's called Karma. And Karma stands for Continuous Autonomous Radiation Monitoring Assistance, and it's been modified to be able to inspect outdoor areas for radiation. So the other robot is called Mirax. It's a 3-legged robot which runs on little roller wheels, and it's got joints so it can drive in any direction. And the idea of this is it's 150mm wide, so it can access nuclear cells which are highly radioactive, so you wouldn't want any humans in there.
But you've done a kind of quite a wide variety of jobs in engineering, so give us an idea of some of the other things you've worked on.
Well, I've kind of took like a different route to the rest of the graduates, and that's kind of why I wanted to get involved in this podcast, to like try and inspire people and make people more aware of like the different routes that you can take to become an engineer and the different careers within engineering. So I started off, when I finished school, I had like no idea what I wanted to do. I just wanted to be like Alan Sugar, like a successful businessman. I thought I'll just like study business and have my own business and that'll be it. But then I was at sixth form and I was studying English literature, history and business, and I was just like, this isn't for me. So after the first year, I applied to get an apprenticeship.
I mean, many people would kind of think the moment had passed, so it was quite brave to do that switch, wasn't it?
Yeah, but I mean, I think like, the majority of people, like when they leave school, like they don't know what they want to do, and like that's not a bad thing. Like I think, if you know what you want to do at 16 or whatever, like good on you, but I think it's never too late. I mean, once I actually understood engineering, like I didn't even think about it, but I thought it's like a perfect mix of like practicality and theory, and like what you're learning, you can like see it applied to like real life applications. So yeah, so I wanted to become electrician, wanted to become an engineer, and I always wanted to have a degree. Like it was always an aim of mine. So yeah, I'd done a electrical apprenticeship in Workington, and throughout my time as an apprentice and an electrician, I studied further education and higher education, where I'd done a HNC and a HND in electrical and electronic engineering, and then I'd done a top-up degree in electrical plant engineering, and then I came across the Sellafield graduate scheme, where like honestly, it's the best thing I've done. Like the opportunities are endless.
What do you gain from going through the route that you went through, going through the HNCs, the HNDs, and going through an apprenticeship route?
To be honest, like it's probably like the best thing I could have done, because I've worked on the tools and I've worked on the things that other people have designed, and then you kind of like get an idea of, say, like how things could be done better. So like say when I worked at TSP Engineering, like my main responsibility was looking after all the plant and like CNC machines and stuff like that.
What is CNC?
It's a computer numerated control. So I was always on like breakdowns or preventative maintenance, and you start to think like, if I designed this, I could have made this motor a lot more accessible, or I could have made this panel more accessible, or you could make things easier to work on. So like, because I've been on, say, the front line doing all this stuff, like hopefully when I come now as an engineer to perhaps like design these kind of systems, I can make them so that they're workable or maintainable, because I've had to maintain that kind of thing myself. And also it just gives you like the fundamentals of understanding like motors or generators or any kind of, basic wiring. I think like everyone should have like a base understanding of these kind of things if you want to get into engineering. So like as part of the graduate scheme, like we do like a engineering skills course, which is like 8 weeks trying to teach people about basic wiring and testing and basic like hand skills and safety, these kind of things. I think that's like really important. But obviously I've done 8 years worth of that, so I feel like it's put me in like a good position now to try and progress.
And what would you like to engineer in the future?
I don't know, like I wanted to use this graduate scheme, this opportunity to get involved with stuff that I'd never done before, like try and throw myself out my comfort zone a little bit, which I suppose is doing this as well today. I've never done anything like this, but yeah, like I'd always wanted to get involved with like robots and stuff, but I'd never had the opportunity before, because I'd always worked on like heavy industrial stuff, cranes or like electrical installation work. So I don't know, I think like I want to become a chartered engineer with the Institute of Engineering and Technology.
But it's a badge of honour, isn't it, being chartered? In acoustics, not many people are chartered. We're a strange sort of engineering discipline, but in some areas you have to be chartered to get anywhere, don't you, if you want to go up the ladder kind of thing?
Yeah, no, I think that's like if you wanted to progress and stuff, like say I need to be like a chartered engineer. But I'm like really proud of like the education that I've done so far, but like if possible I don't really want to do any more now. So now I want to try and like, if possible, achieve chartered status just through like experience. So I've learned 3D CAD, which I'd never done before either, and I've been modelling electronics assemblies to like fit inside small robots. So the one with 150mm maximum diameter of the body, within that it's like really confined, and there's a lot of electronics and stuff that needs to get in there. So I've been like designing assemblies and like 3D printing components to hold things in place and building stuff up so that it's like more robust. This was all like completely brand new to me. I'd never worked with robotics before. I never knew anything about any computer code. I'd never used Linux. I'd never used, it was all, never used any 3D CAD or anything that I've learned here. It was all completely brand new. So yeah, I'm loving it.
In the Inventive Podcast, we're mixing fact and fiction. So we're actually getting writers to write about some aspect of these interviews we're doing. So we're teaming up with Katrina Porteous for this one. So she's a poet from Northumberland, and she's a keen amateur in science. She doesn't have scientific training, but she has written poems about science, like her book Edge. I was wondering what you feel about having a poet writing maybe about robots and their use, or how you've come to become working in engineering.
I don't know. I suppose I feel quite honoured, and I would have never expected like anyone to really want to write about anything that I had to say. So I don't know.
Imagine you have a third eye. Where will you place it?
Yeah, I don't know.
Bit nonplussed might be the best description.
Imagine a sense that allows you to suddenly see in the dark.
It's part of the little fun of this podcast.
Yeah.
Imagine your eyes could unscramble the spectrum beyond the peephole of their own prison.
Hopefully it's beneficial towards inspiring young people to get into engineering.
Think of your fingers making a fist, locking around your phone, its screen, a Stone Age axe at the end of your wrist. The world is moving in its own time, slowly. RANGNC REELUAV SLAMCNC AIIAROV. The world's a sea of problems, dear, but none without solution. So it's 3 cheers for the engineers who set the machines in motion.
So robots in an extreme environment sounds dangerous but exciting.
Yeah, so I'm working on 2 robots. One's called Karma, and Karma stands for Continuous Autonomous Radiation Monitoring Assistance, and it's been modified to be able to inspect outdoor areas for radiation. And the other robot is called Mirax. It's a 3-legged robot which runs on little roller wheels, and it's got joints so it can drive in any direction. I've been working on a lot of experiments on Mirax at the minute because they're trying to make it autonomous so it can drive by itself without being remotely operated.
Imagine that astonishing hand, nerve, muscle, joint, bone, opposable thumbs, slowly evolving. Imagine it moving, independent of the soft, warm animal of your body. Imagine a model of that animal. Where will you send it? Let it explore hazard without risk. Imagine that body, mechanical, imbued with intelligence. Yours.
So, yeah, working for REAL, it's called, Robotics in Extreme Environments Lab. So I'm on like an 8-month design secondment working for these, and then after this I'm going to be moving into the remote handling team at Sellafield and hopefully look to carry on with robotics and other remote handling equipment such as cranes and master slave manipulators, drones, that kind of thing.
Control architecture, programmer, teleoperator of the obedient semi-autonomous master-slave assembly. What are you, human? Unpredictable, fluent, adaptable, emotional, creative, often mistaken. Your charged language sizzles electric. The root of your word robotics stings like a whip. The time has come to speak of collaboration.
So teamwork is very important in engineering. Are you proud of some solution you've brought to a piece of teamwork?
Yeah, so I when I started the graduate scheme, we got straight away working on a graduate project where we got a lot of responsibility to develop a strategy to deal with any large items that we may come across in a nuclear silo. So this is like one of the highest hazards in Europe. So it was very exciting for us all to be working on it. And we were a team of peers. So looking at this problem, working with some of the other graduates, I think for a little while we were probably trying to like overcomplicate it and like reinvent all these like fancy new engineering things to work and manipulate these large items. But like from the past experience that I had, I used to drive overhead cranes in my old job, so I was aware of like different types of lifting equipment that we could use to like lift different objects which are different sizes and orientations. And I took the charge on developing a toolkit that was required to be able to deal with any of these large items that we came across.
A pairing, precise and graceful. Control pad and joystick. The human glued to the screen, careful, remote, guides the machine's individual movements in three-dimensional space, while the brain translates them into a set of equations, control instructions, by which the machine memorizes the complete set of movements. It is a dance, precise and graceful. Human, machine. It rhymes them again and again.
I've been working on a lot of experiments on Mirax at the minute.
In wind-blown green farmland at the edge of the sea, under an iron-grey sky, endlessly unpredictable, a question.
They're trying to make it autonomous so it can drive by itself without being remotely operated.
To be human is to lie awake at night picking at a difficulty. What shall we do to unravel this complexity?
We're currently testing I'm working with some of the postdocs, we're testing the kinematics. So like we run a script, like a code that'll tell it to move in a square or do a figure of 8. We've got an idea of how it'll act, but because of the nature of the wheels and a little bit of backlash in the joints and stuff, we're testing it in an arena where we've got a Vicon system which accurately measures the position of where the robot is in the arena against where we think it should be. So this is what we're working on at the minute.
Imagine untangling a knot, unintentionally tangling it tighter, leaving a legacy. It needs a concrete solution.
Yeah, it sounds incredibly worthwhile, and the legacy of nuclear energy done in a hurry in the past has left quite a lot of messes to tidy up, hasn't it?
Yeah, it's like a real good step for Sellafield to be able to work out what's in these cells, and it helps towards making it safer for everyone.
Grids, boxes, straight lines, cooling towers, chimneys, workshops and warehouses. An immense city, a seething hive of specialisms and impenetrable mysteries brooding on its difficult secret. A priesthood, 10,000 strong, quietly absolving the stain of a generation that blackens in ponds and silos. A shimmering myriad of working parts, an integrated circuit of hope and expiation at the shifting, migrating, wind-battered edges of land, sky, water, elements, life, creating out of a state of uncertainty a clean-edged future. There must be some way out of here, with our schemes and dreams and human hands-on skills and our teamwork, dear, and our flashes of inspiration.
These are areas where people have probably never been.
Imagine you could send your eyes on an 8-month voyage to a rust-red wasteland, parched brick dust and a wind keener than ice. At the dry bottom of an ancient lake, nothing, rubble, stripped stones, pebbles, clay, the upside-down sky dome terracotta. Look, and look closer. Imagine clues in the sediment, signatures in the grit, inanimate rock, stories locked up. The world is information. Whose daring will build a machine like a tree, or the first green algae breathing itself alive in this snuffed-out desert?
If I could grant you a superpower, What would you go for?
I think if it was like just for engineering purposes, I think hindsight would be the perfect superpower.
Imagine a place on Earth as fierce as this, as hostile and hazardous as outer space. Ferocious secrets.
Just because the amount of times like we try to do stuff and either doesn't go to plan, or like even when you finish something it could have been better, or when you really mess something up, like hindsight would have been good to have not messed something up.
Sludge in the storage ponds, liquor in the sump tank, cracked concrete, seeps and leaks, spelks, specks, cactus spikes of deadly light spat out, sly, imperceptible bullets, fry cells, scramble the codes driving the beautiful, delicate instruments, vital instructions for life. Imagine you could send your eyes, your hands, fix the mess, make amends, cancel the legacy, stop the clocks, rewind the years, the race, the pulse, the waste, the ponds.
It makes me wonder what it's like working on a nuclear site. I remember I was cycling with my boys who were then young, and they didn't even want to cycle past the nuclear reactor we saw by the side of the road. I mean, it was quite funny. I mean, what's it actually like being on a nuclear site for real?
Yeah, well, see, this is the thing, like, it's got, like, such a mixed public perception, but I think, like, the more you learn about it, the safer it is. Like, obviously, there's a lot of problems there now at Sellafield because of legacy issues and the fact that it was, like, the world's first commercialised nuclear site, but if you have a look at the modern reactors that are being proposed now, like, they're so safe. Like, the more you learn about them, the safer they are. So, like, for example, like, with the new reactors, like, as the temperature goes up, the reactivity comes down, so like they're inherently safe. Like, and if you look at the accidents and the incidents and even like the fatalities that are in like the nuclear sector compared to the oil and gas or, you know, like coal sector, or even like look at like the rail industry or anything, there's so many more accidents in them industries. But I think like because if there's an accident in the nuclear sector, it can affect like a much wider area. So like that's why it's got such a worse perception, and obviously in the past it was like secretive and stuff, so I think like, you know, it's hard to get away from that bad public perception that sometimes it has. But once you actually like learn the science and you understand the safety and stuff that's actually like put into it, I do feel safe there. You know, so if you follow the rules, like, which there is a lot of rules and there's a lot of safety like in place, which like sometimes people could say it's maybe a bit over the top, but you can understand like why it's there and the purpose of it, and it's sometimes a lot more difficult to actually get things done. But yeah, I really enjoy it.
What's this? Trundling across inaccessible space. A child's yellow truck, stuttering pulses of amplified light.
CAMA stands for Continuous Autonomous Radiation Monitoring Assistance. It's been modified to be able to inspect outdoor areas for radiation, so it incorporates a GPS sensor, a LiDAR sensor. LiDAR is a method for measuring distances by illuminating the target with laser light and measuring the reflection with the sensor. And so like the differences in the laser return times allows you to build up a map of the environment.
Bouncing them off an unseen target. Measuring distance as time. Rangefinder, mapmaker, game, straight out of a teenage bedroom. Avoiding obstacles, plotting your route as an insect might, or a small wheeled dinosaur had evolution taken that path, at a crawl and strangely clumsy, quite unaware of yourself. You're the interface between two eras, oblivious to what your uneven autonomous progress might mean. You navigate between the human and machine, almost intelligent.
You can like know exactly where things are to help with obstacle avoidance and reference points. It's also got wheel odometry, which is used because it's like a lot faster, it's real time to be able to measure the velocity and position. And so this robot is deployed around legacy areas of Sellafield to be able to declassify them so that you know that they're clear of radiation. So rather than somebody actually be doing it by hand where they're at risk of contamination, you can use a robot to do this. You can use multiple robots and you can get things done a lot faster and probably cheaper as well and safer. So the other robot is called Mirax. It's a 3-legged robot which runs on little roller wheels, and it's got joints so it can drive in any direction. And the idea of this is it's 150 mil wide, so it can access nuclear cells which are highly radioactive, so you wouldn't want any humans in there. Once it's in there, it's got a middle arm that lifts up, and on this arm there's a LiDAR sensor and a gamma radiation sensor, and this can also tilt, so this allows the 2D LiDAR to build up a 3D map of the environment so that we can work towards knowing exactly what's in there and help to navigate the robot around the cell, whilst also picking up the radiation hotspots within the cell to then aid with hopefully decommissioning the cell after this.
A tripartite cylinder, jointed, I worm through a hole in the wall, thin as a limb, straight as a die, a long, thin eye, omnidirectional, versatile, nimble, glide on 4 independent wheels, weasel my way in continual metamorphosis, changing form, amorphous, reconfigurable, taking my shape to fit the job as a body should. A sprite, an imp, an elf, an L, a 3-sided U. Raising an arm aloft, I spy a half-finished sketch of a box. Mirax, miraculous. Nothing in nature comes close.
The other thing about working on the nuclear site, especially Sellafield, like there's a lot of challenges that have like never been done before. So for me as an engineer, it's like it's perfect. Like we're now in like the environmental remediation decommissioning phase, so I'm coming in as a graduate engineer now where I'll hopefully be able to get the opportunity to like tackle these challenges head on and be able to like apply like innovative solutions such as like working with the team I'm working with now or any other teams to develop say a robotic solution to come in and improve safety, stop people having to go into these places, you know, which there's potential risk of like contamination or anything. And like make it a lot safer place for everyone that's around here and, you know, probably, I suppose you could say the world really.
A team is more than its players, dear, a machine, not mere components. And the complex springs from the simple things, at unexpected moments.
I think it's sad, really, in the UK that we have this sort of gold standard. You go and do your college education, then you go and do a degree. And these kind of more hands-on roles, which for engineering is vital to understand actually what happens, you know, in the actual device, is kind of looked down on. I mean, it always seems odd to me. Yeah,
and I couldn't agree with that more. Like when I went into my first role at Sellafield, coming in as a graduate, like you kind of like, I don't know how to put this so it doesn't sound wrong, but you kind of like put on like as if you're like higher up or whatever.
Unpredictable, adaptable, fluent, creative, human. The time has come. Let us speak of collaboration.
Some of the jobs that I got given, I was then expected to go and explain to these electricians who were a lot older than me and a hell of a lot more knowledgeable than me. And I was supposed to say, like, this is how I want you to do this job. And I knew fine well from my past that they knew that job 10 times better than me.
Not the model, not the data, not the graduate paper, not the boss with his clean white shirt and his head full of theory, but the sparkies with their screwdrivers. They're the ones who know. Experience. Getting the thing to work on the site, on its own, in the extreme places where the problems are endless and the body cannot enter. There's your challenge. That's the excitement. You need to be inventive. We have to work together.
So I didn't want to come across as like condescending or patronising, like someone like a young graduate coming in like a shirt and pants and saying like this is what you need to do, because I knew even the electricians that I worked with at TSP Engineering, they were a hell of a lot better than me. They knew a lot more than me, and I learned stuff off them every single day. Like whether I had a degree and they didn't, like I had like respect and that for them, and I appreciated that they had a lot more experience and that I could learn a lot more from them. I don't know if that kind of links into what you were saying.
I think it definitely does. I think definitely engineering is very much a collaborative kind of endeavour. And you need the sort of wide variety of skills, all the way from, the actual practical, how do these machines behave in reality, through to, I don't know, it could be computer modelling or predictions and whatever it might be. And actually, it needs to be based on teamwork rather than hierarchical. But in the education system, it seems very hierarchical.
Yeah, I agree, because, I mean, for example, the experiments that I've been getting involved with the team here, like these are a team of academics and they're very, very, very clever, but the experiments never work first time. It's just never been heard of.
RANGNC REELUAV SLAMCNC AIIAROV.
Out of the simple, complex flows from sets and tiers of patterns ingrained in our machines and brains and our human interactions. Crunch, squeeze, grind, grate together. The world is moving in its own time, slowly. Let the mechanical engineer talk to the electrical engineer, the software architect, logic modeler, evolutionary biologist, the neuroscientist, bioengineer, mechanical engineer. In the great marketplace, trading ideas, let them talk, let them listen, let them all converse together, grant them inspiration, let them be inspired by nature.
What I've actually tried to do, there's a team that's just working over the road, which is the remote handling team, which I'm going to be working in next. They get, say, like a robotic system that's like almost ready to deploy this on site. And what I've tried to do is like bring the remote handling team and the team here, like bring them together, because there could be a really good collaboration from doing this, because they know the problems on site, the practicalities of actually getting something there and getting it to work. They're kind of at the forefront of it, deploying the equipment, whereas this team here are at the very low technical readiness level. And like, if the teamwork comes together, it can be so much more efficient. It can make so much more progress, because you get kind of all aspects like involved together.
Who knows where the body ends and the mind begins? Let your neural networks grapple with it. Turn it over in your hands, feeling its edges in the dark. Intelligence is teamwork.
I think probably one of the main skills to be an engineer, I would say, is like teamwork and good communication, because like you don't know everything yourself.
Imagination leaps, darts, playfully censors and worms into places logic cannot, as Karma and Mirax venture under logic's control where the body dare not go, its own extension.
Once I actually understood engineering, it's like a perfect mix of like practicality and theory, and what you're learning, you can like see it applied to real life applications.
And the outcomes of actions will be inputs for further actions, says the controller of the advanced automaton. And the difference between the actual and the desired value of a process variable is the error signal applied as feedback, says the complex system, evolving emergent properties of spontaneous order. Grant us the gift of rapid autonomous navigation, simultaneous localization and mapping of myriad parameters. In your decision-making software, let there be many degrees of autonomy. ROV, CNC, GNC, ransack, slam. Who will translate to warm-bodied humans this thicket of acronyms?
In my past working on CNC machines, my background's electrical, but CNC machines are often multidisciplined, so like I would need to work well with the mechanical maintenance team. I would need to be able to communicate well with like line management, so like they're aware of what we're trying to do. team leaders, and also I think like it's good to even have like a good relationship with the machine operator, because although they're not like say electrical or mechanical maintenance craft, they know that machine and that system better than we do because they work on it every day. And it's the same with like process workers or like anyone in any form of life really. You need to be able to have a good relationship with people, good teamwork, and communicate effectively and stuff to overcome any problems that you face with.
There must be some way out of here, with our schemes and dreams and human hands-on skills and our teamwork, dear, and our brave imagination. So it's hey, hey, the logic gates and the streams of information, and it's 3 cheers for your bright ideas and your flashes of inspiration.
And what kind of struck me there is you talk about you want to work on stuff where there's new things to be tackled, so there's creativity needed for you to find new solutions. Is that, would you say creativity was a skill that an engineer needs?
Yeah, definitely. I think like as an engineer, like you're always inquisitive and you always look at how you can make things better, or like better ways of doing stuff. So these are areas where people have probably never been.
Among the constellations of space junk wheeling above your head, imagine a robotic arm with 6 degrees of freedom. Its surge, heave, sway, its roll, its pitch and yaw, unfolding, a precision instrument, a litter picker, its grasping algorithms and its color depth sensor, strength, dexterity and stiffness. Think of a lobster claw snatching its prey in the ocean's dark. How long it takes to make a hand to lift a cup to drink.
I think you've got to be good at like solving problems, and sometimes to solve problems you've got to be creative, you've got to be able to think outside the box, but there's also like the point of like applying known engineering theories and stuff to overcome stuff.
You've landed in a really good field in robotics, haven't you? I mean, there's so much investment in robotic technology, and it can be down to things like factories making foods and stuff like that. But I guess it could be even going to the moon and doing stuff with robots on the moon and stuff like that.
Yeah. I think like the opportunity is endless, really.
It sounds so simple. The search for carbon compounds and light elements. Hydrogen, oxygen, nitrogen. A box the size of a microwave oven. Curiosity is doing it on its own. Sample analysis on Mars. A wheel of small cups containing scooped soil, drilled rock, thimbles of solvent, miniature kilns cooking its samples to vapor. The mass spectrometer screening them into their elegant tables. Out of these numbers, worlds flow. The samples, ancient clays laid down in oceans, volcanic crystals, splitting an X-ray beam at specific angles. Slow oxidization and rust. How simple a process history is. Metamorphosis, minerals, rocks. And the long road to knowing this, how complex.
This was a case of, say, like we didn't have to reinvent the wheel, like we could use equipment that was already available, equipment that, really isn't that complex if you're aware of it. So this was like a good way that I was able to apply like my past experience to solve like a really important problem.
Ingenuity has photographed perseverance. How lonely it looks down there in the rosy desert. An animal raising its head, slowly gazing about it, seeking its likeness. The most advanced organization of parts peering into the most primitive, ancient microbial life. What does it look like? The tide has gone out forever, leaving nothing but sand, grit, stone. And this creature, all on its own, out of place and time. An arthropod dropped down, a dinosaur, tortoise slow and deliberate, mirroring something. What do you feel? perseverance, ingenuity, such noble virtues, reason, precision, daring, collaboration, embodied in wheels, springs, motors and circuits. The drone gazing down at it from on high like a god. Surprisingly sad, its immense solitude, tearing the heart that still beats, that is there to be torn.
When I started my apprenticeship, there was people just starting it at like 24-year-old. You're never too late to change and do what you want to do, like what's going to make you happy. I don't think. People put a lot of pressure on themselves, like thinking like, oh, I don't know what I want to do. I don't know what I'm supposed to do or what people expect me to do, but try and be open to all things. Like I was like kind of blinded by just wanting to be like Alan Sugar, maybe like a little bit, maybe immature or whatever. Like I just thought I would go and like study business and that would be it. But another good quote, I think like someone said to me when I first started the graduate scheme, can an engineer be a businessman? And well, yeah, you can. Like you can be an engineer and run your own business. He says, but can a businessman be an engineer? You're like, well, yeah, if they want, but then they've got to go through all the training, like apprenticeships or a degree or something to do that. So I feel like engineering's like really good in that point where like it goes into everything, like across the world, like everything you look at involves engineering in somehow. And I think it's like such a good career that the world will always need engineers.
Imagine this, a robot on the moon. Is it a solar-powered rover? Clever wheels clambering over boulders out of holes, learning by reinforcement to control load distribution, traction on loose soils. Is it a pair of hands snapping bricks 3D printed into walls, houses, habitats? How does it operate? Does it send signals back to somebody waiting? Maybe an astronaut orbiting round it, sharing its eyes, touch, sense of orientation, where it is in space. Is it a beautiful thing, a robot? The moon? Human intention? Their interaction, a dance moving from teleoperated to autonomous? Do not try to answer this question. Sometimes a place luminous from a distance turns out desolate when you arrive. Beyond the light of the sun, worlds that cannot support a life with water or oxygen wait for the robots mapping, drilling mines. If we are not there now, we will be soon.
A quote from you is, you get out what you put in. Maybe you could unpick that a little.
Yeah, the reason that I put that is because I've like doubted myself in the past.
Out there in space, the machines are doing it on their own. A claw plucking litter from the dark. A process analysing alien rock.
When I went to do a degree, like I always wanted to do a degree, but I started thinking, I don't know if I'm good enough to do it.
And close at hand, in the dangerous places, the pile fuel sludge storage ponds and silos. They are working alongside us, positing their difficult questions in silence.
Then when it came to getting on the graduate scheme, like I looked at it and I thought, oh my god, that looks like brilliant, but I don't think I'm clever enough to do that.
There must be some way out of here, with our schemes and dreams and human hands-on skills and our teamwork, dear, and our brave imagination.
But then, I don't know, when I started my degree, I thought, like, if I get a pass, I'll be over the moon.
Imagine a machine. Its mobility function excellent over rough terrain.
And then I thought, well, if I put the most effort in that I can, and whatever I get out of it, I can't have any regrets.
Its light sensors, complex image recognition, memory mapping in 3 dimensions, twin actuators, manipulators, degrees of dexterity, grip, robust enough to flex iron, gentle with eggshells.
So I just like put in maximum effort, and then next thing I was like, I can actually achieve a first class here, and I achieved a first class, and I thought, I would have never thought that I could do that.
Imagine it could not exist in isolation, but only with others like it, linking up its system of mirrors, its logic encoded in symbols, allowing it to reflect on sameness and difference, enmeshing it with its other selves in their millions, its networks lighting up its habitats, visible from space.
And then there's people that I worked with, they were like, Jack, like, you've got like such a good foundation of engineering knowledge, and you've done a degree, like, you'd be perfect on that graduate scheme. And once like I kind of built a bit of confidence, I was like, yeah, do you know what, like, I can do it. And if you set your mind to something, like, I think you can achieve it, like, so long as you're willing to put the effort in. And if you don't put the effort in, like, you're not going to get much out of it, really.
Imagine those networks knitting into one machine, entangled with the machinery of a planet that sends its delicate instruments into orbit, weightless as thistledown, to fire back information. Imagine it gazing at itself from a great distance. What is that ache? Where is it felt? What does it mean? Imagine it able to recognize itself from this description. RANCNC, REELUAV, SLAMCNC, AIIAROV. How far away they are, out there among the stars, the machines of the future. Too far to recognize bodies, objects, landmarks, unexpected shapes, feelings, the sudden dust storms sweeping across Mars. The world is moving in its own time, slowly.
I think one of the fears about robots, sort of in the popular press, is they're going to take all our jobs. There's certainly been reports about how many jobs they might take. Do you think that's something we should be worried about?
Yeah, and I know this. I see this point as well. Like, to be honest, even when I go through the supermarkets, I like to, use the people on the tills as well. Just you don't want to be putting them people out them kinds of jobs. But I think like the robots that I'm working on are there for a purpose of making things a lot safer, because they're removing the risk of having somebody in that environment which is really harmful. So I think these kind of robots are, this is what we need. I mean, I wouldn't want them to do too much. My girlfriend, she wouldn't be too happy if we were designing robots to take her job.
You can see it from space, an ancient planet. Across its scarred surface, homes, schools, businesses, offices, cities flicker a brain scan. Adaptive, emergent, highly distributed networks, connecting together a myriad ways, generating synergies. Do they augment us? Will they replace us? What will be lost to us in their implacable reasoning? For it's hey, the logic gates and the streams of information, and it's 3 cheers for your bright ideas and your flashes of inspiration.
I feel like engineering's like really good in that point where like it goes into everything, like across the world, like everything you look at involves engineering in somehow, and I think it's like such a good career that the world will always need engineers.
The machine in your pocket buzzes. Already it can recognize your face, but it does not know the answer. It does not know what it knows, or what is at stake. Your privacy, your job, your life, your species.
If I could grant you a superpower, what would you go for?
I think if it was like just for engineering purposes, I think hindsight would be the perfect superpower.
Free in the sunshine, under the trees, the next generation, fresh out of school. You. Who will you become? The small, the enormous questions.
Just because the amount of times like we try to do stuff and either doesn't go to plan, or like even when you finish something, it could have been better. Or when you really mess something up, like hindsight would have been good to have not messed something up.
At night you unpick them while the planet spins, the stars obscured by the light from a billion screens. the blinding ice or the burning forest? What does it mean to be truly autonomous? Human, machine.
If you're going to give us a superpower, I think I would probably prefer to fly, but yeah, if it's just for work, I'll go with hindsight.
Yeah, I guess engineering is a kind of trial and error process, so I guess shortcutting that would be really, as you say, really useful for work.
Yeah, a lot safer as well, probably.
Scroll down the menu as the world unfurls, fractal, endlessly possible. Its clever solutions filter the choices determined by pathways locked into its software, sets of instructions subtle, invisible as radiation, invade us and alter our circuits and networks. Control and autonomy, servant, master, body, mind, machine, uncomfortable jargon, slippery as nature. Its endless unfolding, relentless self-organization. In the evolution of complex systems, the time has come to speak of collaboration. Out of the simple, complex flows from sets and tiers of patterns ingrained in our machines and brains and our human interactions. A team is more than its players, dear. I want to step inside you, computer, not the chip in the brain, not the implant under the skin. What logic and process cry out for is randomness. Inside the machine, the music of human feeling, imagination. Yes, there must be some way out of here with our high-tech kit and human hands-on skills and our synergies and flashes of inspiration.
Once I actually understood engineering, I didn't even think about it, but I thought it's like a perfect mix of practicality and theory, and what you're learning, you can see it applied to real life applications. So I wanted to become an electrician, wanted to become an engineer, so yeah, I'm loving it.
Have you sent your third eye ahead of you yet, into tomorrow?
The opportunities are endless.
It's waiting for your fingers to make a fist, locking around your tools, your phone, the Stone Age axe at the end of your wrist. How long it has taken nature to craft that complex contraption to grip and lift a cup to your lips. But you are engineering your own future. You and the clever machines. Can you imagine it? Now, make it come true.
The Inventive Podcast, mixing engineering fact and fiction.
It's really great to hear the words which I wrote brought to life through Adam's sound design. I love this part of the collaboration of creating a piece like this. And I know that Adam used a servo from a robot as the basis for his sound design in this piece, and using that constraint and then finding a sort of freedom within that constraint and that kind of problem solving. I think that's such an incredibly creative thing to do. So it's just great to hear it brought to life.
And interesting enough, that creativity within constraint, which is so important to artistic endeavour, is also really important to engineering. I mean, particularly when we're solving real life problems, there's always constraints. And I guess as a poet, there's always constraints to what you might do. Yes,
absolutely. And poets impose constraints upon themselves by using particular forms, and structure and form in poetry is extremely important. So you always, it's all about problem solving. It's all about as human beings, that's what we do. We're problem solvers. So whether we're doing it with words or we're doing it with engineering solutions, in particular practical problems, the approach, I think, is very similar.
That's fascinating. I mean, the other thing I noticed that you took the scope of the interview and you kind of expanded that to look on a sort of geological timescale.
Yes, this is something again which has interested me for most of my writing life, really. And working with scientists has been fantastic because I've actually been able to find out really more about what I've been intuiting for a long time. But if you can find out the hard science behind it, that's fantastic. So I suppose, particularly at the moment, we're in the middle, as we speak, of the climate change conference, and we're all incredibly aware at the moment how much our very survival really depends upon the choices that engineers make on the solutions which engineers can come up with. You know, our Anthropocene activities are balanced on a point where we could either be engineering our own extinction or our escape from it. And that's an incredibly powerful place to be. And I think this whole idea of collaboration, both of human collaboration and also this idea of some kind of cultural evolution of human-machine hybrids, humans and machines working together, so that the logical power of computing and the imaginative power and emotional power of human consciousness, if those two things could come together, that's the most incredible, powerful collaboration, really, for the future.
And a nice optimistic message, because I think actually with the climate emergency, it's very difficult to feel optimistic about a lot of that.
Yes, you're right. I live by the sea and I go down onto the rocks every day and I look at the fossils in the Carboniferous rocks outside where I live, and they are about 300 million years old. And in that time there have been several mass extinctions and many, many sea level rises. And we put our own human life, which is at the very most, you could calculate it at about 1 million years. When you see human life in that perspective, you know, you begin to feel that there's a sort of comfort in it, oddly, and a sort of empowerment in it, because what that does for me is it brings me back to the present moment, and it makes me feel that the joy and our experience of nature in particular in the present moment is incredibly important. And where our empowerment lies is in sensing that joy and sensing what is close to us and what our own physical senses can grasp and responding to those. And I think that sort of message of caring about the environment beneath your feet and what's around you every day, that's what I feel as a poet is the starting place for trying to do something about the ecological emergency, not just the climate emergency, the ecological emergency. You know, the word engineer comes from a Latin word, ingenium, and that means something innate, something which is a natural quality. And we also derive our words ingenuity and genius from that. And I just love it, that the idea of engineer actually comes from something which is in nature.
And we've had people on Inventive to actually talk about how to be an engineer is to be human. You know, it's part of being, we've always done it.
Yes, I think that's true. And I think, you know, we are all problem solvers. So we all have the imaginative skills to be engineers.
Yeah, lovely discussion, Katrina. Lovely to meet you.
Thank you. Thank you very much.
Inventive.
Well, a big thanks to Jack Haworth, our engineer for today, and also Katrina Porteous for her thought-provoking poem Ingenious. I was really struck by how we went from robots navigating between humans and machine to them helping us to navigate the future. Hopefully that's a future where we don't create contamination that needs cleaning up. Well, that's series 2, and we've covered quite the ground, from natural disasters to space travel, from green energy to robotics. And what brilliant pieces our writers have made, including some firsts for us, a rap, a poem, and even a witty short story. If you've enjoyed Inventive, please subscribe. You can go onto one of the podcast apps and comment as well. That really helps us become visible. And at www.inventivepodcast.com we have a survey form for our listeners, and there you can give us feedback but also suggest writers and engineers we could work with in the future. There are school curriculum and career materials also on the website, or you can go to NU STEM at Northumbria University, who are producing them to download. Thanks to Anna Scott Brown and Adam Fowler, who were the producers. Inventive's music was by Brendan Williams, and we've got animations created by Annabeth Robinson. Images were by Ben Warburton. Jill Davis is doing the multi-platform and social media content. The Inventive Podcast is from the University of Salford. It is funded by the Engineering and Physical Sciences Research Council, and the podcast is an Overtone production. So it's goodbye from me, acoustical engineer, Professor Trevor Cox.
Inventive.